right. Hello, everyone. I'm going to be waiting for the next minute or so to make sure that everyone wants to be here can actually be here. As you can see, I'm not in my usual setting. I'm not in my room. I'm out in my garage because if you notice that there is, in fact, two of me, I do have a camera set up right there so that I can show you all the tools that I took from the lab and will be using to help teach you guys fabrication. So basically, I have the big three, I guess as you could call it. Right here is I have a drill press, and then there's a mini mill right here, and then over here, there is the lathe. So you don't need to know what they are yet. I'll teach you guys that in time. In fact, I think next week is the time when I teach the drill press. So it'll be fun. The reason why I'm out here, I just wanted to get used to making sure there was nothing keeping me from having a normal meeting out here, because obviously in the garage, the internet speed kind of sucks. It seems like I can get around that. So, all right, John. Anyways, I think we're just about ready. And so, yeah, good. Today, I'm going to be giving a presentation about safety. I'm going to go pretty deep into it. I know that last time I already talked for like at least 15 or 20 minutes about safety, but this time it's going to be a little bit more in depth. And I'm also, again, I'm recording this meeting, as I will record future meetings. So if you send the media okay, that's fine. And if you didn't, then just turn your camera off, whatever works for you. It doesn't really matter. As long as I know that you're participating, we should be good to go. So no one has tried to go in for the past couple of minutes. So I think I will begin. All right, you guys can see this, right? All right, nice. Okay, so originally I was planning to have this week be based off of safety specific and using the bandsaw, but it seems like, well, basically we're in the process of moving out of our current lab, and we weren't able to have access to that over the weekend, which is what I was counting on to record a video of me using the bandsaw that I could show you guys. Unfortunately, that did not happen. I will have a video in the future. I will also make it a point after COVID measures can be don't have to be taking place anymore. I will make it a point that each one of you gets hands-on experience using every tool, including the bandsaw. But that just can't be done right now, unfortunately. I will definitely have videos of me properly using every tool within the slide. I'll incrementally record those videos each week, and that is how, in addition to these like Zoom meetings, you'll be able to actually learn how to use the tools. In addition to later dates that are currently unspecified, in which you will get hands-on experience. But for now, it's time to learn all about safety. All right. So, general safety guidelines. Hang on, I have a prop for this one. Safety glasses. I said that you need safety glasses on whenever you're using the tools. Probably 10 or 20 times last meeting. Well, I'm going to say it like again. You always need these things, all right? These safety glasses, they're really nice. They fit over my glasses, as you can see, so I don't have to be blind when I use them. And we have glasses like those at the lab. We also have just normal, like really run-of-the-mill, like clinging to your face glasses that don't really work with people who wear normal prescription glasses. So we do have the proper safety equipment for people who wear glasses and don't. So this is still the biggest thing about safety here. So I need to remind you guys. I'll also be reminding you guys every time I teach a new tool, and it'll be so ingrained into your head that whenever you step close to a tool, you'll hear me yelling at you, "Wear safety glasses, wear safety glasses." And that's kind of what I want, because the alternative, I know it might be a little bit annoying, but the alternative is much worse. So that's what you have to deal with, I guess. All right. So the hand rule is, so for example, if you have a piece of stock aluminum, which I have right behind here, like this is what I refer to when I say stock aluminum. This is just a piece of 2x1 aluminum extrusion. Let's say I'm at the drill press, right? It's coming down. Actually, if I really wanted to, I could demonstrate it on the drill press right over here. I'm using the drill press like so, and the drill is right here. It's not a good idea to have your hand be so close to the drill bit right here. What you want is to have your hand be about 1 hand length away from the drill bit, or whatever moving part of the tool is in use. So that's very obvious for the drill press. And we have other smaller tools like clamps and vices in order to secure the part that you're working on while you're using the tools that I will teach you when the time comes. But for now, what you have to remember is that gripping gripping the part while you're using the tool that is less than the length of your hand away from whatever piece of the machine is cutting away material. That's not a good idea. You should avoid that at all costs. And if you do so, you should be safe. All right. Because, okay, so basically the risk of having your tool, of having the tool be super close to your hand is that oftentimes you see, especially when people are just learning the tool, is that if they don't clamp a part down or use the vise quite correctly, there's a risk of the tool like coming out of the vise, and obviously being under the influence of whatever moving part is on the machine, it can probably start spinning around. And if your hand is right next to there, that can be disastrous. So we want to avoid that, and that's why I implement the hand rule. That's also extremely important for tools like the table saw, because that is one of the more dangerous tools in terms of having your hands be injured. And we want to remember this rule, especially for that. And again, I said this before, in terms of clothing, if the clothing is super loose, if you have long, baggy hoodie sleeves, if you have long hair, it's a good idea to try and tie it back before you use a tool. If you have hoodie strings again, or open-toed shoes, be sure to avoid that before you're using the machine. You can, if you're using a hoodie, you can just hike the sleeves up your arms. If you have strings on your hoodie, you can just tuck them into your shirt. And just assuming you don't wear flip-flops to school on the regular, then the open-toed shoes shouldn't be a problem. So anything that you would wear to like PE or even just day-to-day outside, those shoes should be fine for using a tool. And again, proximity. We use a 6-foot rule of thumb. If you're 6 feet away or closer to a tool that's being in use by someone else, then what you want to do is to wear safety glasses in that proximity. All right, that was weird. Right, everything good? Okay. So, and we also, at the previous lab, obviously if you imagine our lab is in like a big space, there was one section where we had most of the power tools, and it was separated by this white and red striped line that basically denoted that if you cross this line, you have to wear safety glasses. We probably won't have the same area, the same size and shape. We might have something similar to that. I don't know yet. What we have to do is just sort of play it by ear. We probably will have most of the tools in some area where you will have to have safety glasses to enter. So again, just entering that zone, make sure you have your safety glasses on. So yeah, normally we would have like all the safety glasses in a single bin right outside of that area. So super convenient. Again, I don't know what it's going to be like in the future, but I'll make sure to inform you guys because that's what's important to keep you safe. Okay, so that was just a quick brush up on types of safety that I've already sort of explained in the past, or last week, I should say. And what I'm going to do now is to go more into specifics about different types of dangers that you can safely avoid, or different types of hazards. Alexis, steel toe Crocs, if you have them, would be appropriate to wear if you're machining. So all tools make a part hot. For example, if you drill into some metal, you're going to make it warmer. If you use the lathe and cut across it, you're going to make the lathe warmer, or you're not going to make the lathe warmer. You're going to make the part a lot warmer. Especially if you grind something down by a sander or a wheel grinder, you're going to make that part very hot. So what we need to make sure of is for you to just be aware that whatever part you're going to make, by the time you're done machining it, it's going to be a lot harder than when you put it into the tool. And again, aluminum is really, really good at conducting heat. So it will get hot easily and very quickly. So you just need to make sure that you're not going to burn yourself if you actually, if you do use a tool and you cut down a lot on the metal, because it can get hot enough to burn you if you aren't careful. And so to identify whether or not a part is hot, because it's very hard to determine that, because it's not like a fire. You can't just put your hands out because it's such a small part you won't be able to notice. So what you can do is that the parts of your hands that are very sensitive to heat are like your fingernails or the inside of your wrist right here. So if, let's say I have a part that's hot off of the lathe, and like, let's say this was the area in which I was machining it down. So I can assume that this part is going to be quite hot. What I can do is I can bring my fingernail really close to that part, not touching it, but I would be able to feel the heat from my fingernail or my wrist, whichever one works for you. I found that a lot of my hands have calluses on them, so it's hard for me to judge heat anywhere else. So whatever works for you, whatever makes you safe, is what's best. And also coolant. I also have a prop for this. This is the coolant that we use. It's this blue compound that you mix with water. We have a bunch of little squirt bottles, and we just have these all across the lab where we use our tools. What that does is you would spray that on a part that you just got done machining, or during, if it's a long process. If it takes a long time to fabricate that tool. Yeah, right, John. Some of us have made mistakes with almost burning ourselves. I remember a couple of times I took something out of the lathe and I kind of did actually burn myself, but that's why you need to be aware of heat safety. What you need to do when using coolant is that, let's say if you're machining something on the lathe or the mill or the drill press, and it's going to take several minutes, and you know it's going to get a lot of heat trapped in the part, what you do is every 30 seconds or so, you just spray whatever part of the metal is being machined off right then and there. Just spray that area a couple of times, and then you will significantly reduce the heat of the part and make it so you don't burn yourself when you take it away. Also, this doesn't really apply to aluminum very much, but especially with steel, is that if you make steel really hot when you're machining it, there could be problems in terms of that process. We won't need to worry about that very much, but it's still important to learn about practicing using coolant correctly, because in the future, if you're all master machinists, you're going to want to learn how to use coolant properly. So it's just a win-win situation. All right. So fire safety, or more specifically, safety, keeping yourself safe from sparks. So there are only going to be a couple of tools that we use regularly that's going to generate any type of spark. And it's not going to be just from aluminum. It's going to be when we're cutting down like steel bolts or something. So these tools are going to be grinders, Dremel tools, and yeah, like belt sanders and stuff like that. And they're only going to generate sparks when you cut through steel. And obviously the sparks go in the direction of wherever the tool is going to apply abrasive material towards the part. Let's say if I have a belt sander, I have some sandpaper on the belt sander that's going down, like it's just continually going down, and I have the part, and I stick the steel part to the belt sander, the sparks are going to go downward. So it's important to keep that in mind, because if you are generating sparks in a direction that is very near something flammable, like a piece of paper or some sort of, I don't know, gasoline, you're going to want to avoid doing that, obviously. So most of the time, if the sparks touch your skin, you won't feel it, you won't get hurt. But especially with angle grinders and some disc grinders like benchtop grinders, they can generate small particles of metal that fly off, and that can burn you to a certain degree. If you are using a bench grinder, the metal sparks or the metal bits won't fly anywhere near your face, but it's important to make sure that whatever you're doing, the direction of that metal and the sparks is not like directly at you. Most of the time, it's best to just make the sparks fly into the ground. And so the proper safety equipment for using a grinder or a sander is to use a spark mask. And if the part is small, also gloves. And what I mean by if it's small is that if you have to grind down or sand down a small part, you're going to have to use pliers to hold on to it, because otherwise it would get way too hot to handle with your bare hands. And the gloves will protect your hand from the tiny bits of metal that go off and hit you, and that because obviously you have a risk of those bits of metal hitting your hand. Also, gloves aren't recommended for every operation with sparks, because, for example, angle grinders and benchtop grinders, you have a chance of getting the glove caught in the disc that is cutting the part, which can be a disaster. So we want to avoid that. So gloves for belt grinders only. And also, you should also have coolant or water, because these tools are especially good at generating heat in the parts. So it's good to have, especially like if you just have like a tub of water nearby, you can just dip the part in water. You get to look like a blacksmith. It's pretty fun. And also, sparks lead to a fire risk. We do have some fire extinguishers in our lab, and I would have pointed them out to you, except for the fact that, again, we're not going to be returning back to that lab. I will inform you all of the location of whatever fire extinguishers are most nearby to wherever we're going next. All right. So when you're in a competition, it is not particularly dangerous, but there are some things to keep in mind that you wouldn't need to keep in mind otherwise in the lab. So this next point is mostly on the responsibility of the safety captain of the competition, which most times has been either Sid or me. So basically, there's always a chance that some sort of fire or competition or other threat comes while we're competing, and we need to have some sort of a plan to safely and effectively evacuate. This is something that the judges have asked us once. We didn't really have like a super flushed out plan. They sort of gave us a hard time for it. So it's just nice for either me, Sid, or someone else to have some sort of a plan in mind so that if something bad does happen, none of us get hurt. All right. So in terms of the pits, there are a few things to keep in mind. Yeah, everyone's sad about the lab, I know. So obviously the pits are super crowded. If you guys ever get the experience to go to a competition sometime soon, a lot of you will probably get to be in the pits at some point or another. It's really fun being in there, but it's also quite crowded. And so also it's important that since our pit is very small, it's only like 10 feet by 10 feet for each team. If there are too many people in there, not only can it get sort of, it's crowded and it's not fun for anyone, but it's also not quite as safe because if someone is using a tool in the pit, not everyone can keep a safe distance away from that person. Everyone's going to be wearing safety glasses, but if it gets to the point where you have to be right next to someone who's drilling something, that's not ideal for safety. So we want to make sure there are a limited number of people in the pit. In the past, I think we've limited it to like 8 or 10 people. That seems to be a good number to reach for, but I don't know what we're going to do in the future. And when we're moving the robot from the pit to the competition area, it's important to let other people know who are in the hallways, like the halls between the pits, to let them know that we are moving the robot. Most of the time in the past, we've just called out robot, and then everyone was, or at least everyone who heard, they all have the common etiquette to get out of the way. But recently, like in the most recent competitions, there have been some people objecting to that, and some of us have decided we just want to just have one person go ahead of where the people are actually moving the robot and tell everyone quietly that there's a robot coming nearby. So be prepared for either one of those whenever we next have a competition. And so yeah, that's about it for that. So if someone is enabling the robot, it is their responsibility to yell out enabling in the pit before they actually turn the robot on. And it is your responsibility to make sure that you are not touching the robot when it is being enabled. And this is because of a previous incident that happened with the president my freshman year, got a bit of a finger injury when his dad enabled the robot and he didn't take his hands off. So we have a very real life example to go off of for why this rule is important. And it's basic, there's not a whole lot else to it. And also when you're in the pits, there should be no running or yelling, and make sure to wear safety glasses at all times. There will be a bunch of people to remind you if you're not wearing your safety glasses. So you won't need to worry a whole lot about remembering when you're at a competition, but it's not going to be too bad to do that. So in terms of the competition field, there will be some sort of meeting before the competition where the safety leads have to go. I think in the past it has been the same meeting where like the drive team also wins, and they just discuss a few things that you need to be safe, and that's pretty much it. It's just something that you sort of have to do. You just pay attention and make sure that you got it all under control, and whoever is the safety captain during that competition should be good to go after they get that debrief from whoever is running the competition. All right, and that's where I wasn't able to continue the presentation because I did not have the ability to film myself using the bandsaw. So I see a bunch of chat notifications. You all are clowning on Jack. All right. Um, yeah. In terms of safety, that's pretty much all I wanted to cover. I would like to talk for just a couple of minutes about what I have planned for the future, because I'm not sure how clear I've made it in the last meeting or in this meeting so far. So I'm going to stop my share, and I am going to refer you all to my phone camera. Hello. And I'm going to show you the sort of setup that I have right here. So again, I showed you guys the drill press, the mill, and the lathe that I have right here. And this is where my garage is, where I will be teaching classes for the foreseeable future. And I want you all to know that I also have like hand drills and circular saws and a portable table saw that I don't have right here right now, but I do have all of these resources to make sure that you guys know how to use all the major tools that we have in the lab. And what a typical lesson will look like, probably starting from next week until November or December, is that I will invite you all to the meeting, just as I have today and last week. We'll get on, and I'll have like a really short, like maybe 5-slide presentation, and I'll probably show the video that I made during that past week, where I just filmed myself doing all the basic operations of the tool. And then what I'll do is I'll, in real time on Zoom, design some sort of part that requires me like machining out every operation that you can do on that tool. So for example, if I have a drill, I can really only do one thing with it, and that's to drill holes. But if I have like a different tool that can do 2 things, I'll make sure to design a part which requires those 2 things to be done on a block of aluminum, so that when I am recording myself using the tool, you guys will have an understanding of what needs to be done in terms of operations on that tool to actually use it. And in the future, again, I'll make sure everyone has the chance to use that specific tool and learn how to do all those operations by themselves, because there is a very big difference between me showing you online how to use that tool and you actually doing it yourself with your hands. Because there is an element of learning that happens when you do learn a tool with your hands, and I think it's very important that you all get that experience. It just can't happen right now, and that is also part of why I am recording all of these meetings, so that you guys can get a refresher when it comes time to actually start using the tool. And that's all I wanted to say for that. And basically the next 8 or 10 meetings will just consist of that sort of live Zoom meeting. You guys can ask questions either through chat or through asking me through voice or whatever. And we'll probably have some other discussion. I'll probably involve you guys in actually designing the part, like, you know, some sort of measurement or challenge or something of that nature. And it'll be pretty fun, I think. And what I want you guys to do is, if you have any questions, to share them in the chat. Since I was planning on presenting a little bit on the bandsaw, I did not, I only allotted like 30 minutes for the safety presentation. So I'm not stressing out about the fact that it's only 4:30. Doesn't really matter if this meeting is a bit shorter than the others. You know, it doesn't take that long to learn about safety. It does take a little bit longer to learn how to use like different tools or whatever. All right. It doesn't seem like anyone has any questions, but that's all right. I wasn't exactly expecting like an onslaught of questions from a safety presentation. I think that if everyone is clear on what I presented so far. I do have, if you all are part of the robotics main uh, Google Drive folder, I do have these slideshows on the fabrication folder of that robotics main Google Drive. And what you could do is you could just access them if you want a refresher on any of the information posted. I'll also, starting with this meeting, again, just as an extra reminder, be recording them, each of these meetings. So if you want to re-experience this meeting, then you can if you want. But other than that, I think I'm going to say goodbye, and I will see you next Tuesday at 4. And I think it's going to be using the drill press for the hand drill. So that'll be fun. You'll actually start learning how to use the tools. And it will be the start of an amazing adventure. All right.
Thank you.
Yes, indeed, Kenneth. Yeast. Ah, Yuda and Clement.
Are we ever gonna come back in like December somehow?
I'm not sure what'll happen. December is the time I was having in mind to finish these Zoom heating lessons.
I see.
So, yeah.
I mean, if the school is gonna allow sports to reopen in December, then does that mean like we could technically do it again in December?
The school doesn't treat robotics and sports as the same thing or like on the same level, which is, kind of stupid because, we're pretty involved in terms of clubs, but
Yeah.
I'm not sure what the future is going to hold. I'm not in really good communications with the principal or any of the staff, unfortunately. What I can do is just kind of go with the flow for the moment. So, yeah.
Okay. Thank you.
Yeah, thanks.